Hello, everyone. Welcome to our next event in our series, Meet the Experts. And before I forget it on the very end, please always check out all these new Meet the Expert sessions coming up in the near future, because we have a wide range of really, really good presentations in the near future. So use the opportunity, check it out on the EFI side or on the EACA side. But for now, I would love to say once again, a warmly welcome to all of you guys for this really thrilling topic. And not only a thrilling topic, it's also a key related to our new Masters of Business Management, Financial Crime, and Digital Technologies coming up and offered by the European Forensic Institute. Let me take the opportunity at the end of these presentations to give you a briefly overview about this new master's course. But now, a warmly welcome to our guest speaker today, Julian Tymiński. He is an intelligent analyst consultant from the GraphAware company. And I would love to give the floor to Julian right now so he can talk a little bit about his person, also about the company, and then let's go and see his outstanding presentation. So Julian, the floor is yours.
Thank you. So I'm Julian Tymiński, as it has already been said. I used to work for the Romanian Defense and for NATO for the past 15 years. I worked in intelligence, different branches from all source analysis to human analysis. And now today I work with GraphAware together to develop very beautiful software that you will soon see. Speaking of GraphAware, I would like you to share some thoughts about our company. So I hope you guys are able to see my screen. We at GraphAware help organizations gain a competitive advantage using graph-based intelligence analysis. We're founded in 2013 in London, and we have legal entities all over the world. Our main customers are from local and federal police forces, intelligence agencies, cyber defense and cyber intelligence organizations, and we also serve customers from insurance, bank, and retails, helping them analyze mission-critical data to solve their worst headaches. Our team is comprised of experts in graph data science, conference speakers, technology enthusiasts, which sets us at the edge of development in graph technology, large language models, and intelligence analysis. So what are graphs? We believe that the world is connected, and the tools that we use today to analyze that world are obsolete. Using tabular-style databases, we cannot describe anymore the complexity of today's world. On the left-hand side, you can see a classical tabular representation of data, while on the right-hand side, you can see a graph representation of data. Graphs combine entities and relationships to provide the entire ecosystem, the entire world in a single place, while the tabular style databases only provide a slice of that data. In Hume, we represent data using a schema. So on the slide, you can see a representation of a schema that is designed for law enforcement use cases, but the schema is very flexible and can be adapted to any type of use case you might have. Here you can see that we can bring all types of information from camera readers to open source investigations to cell phone data, so on and so forth, bringing all the data in a single place for the analyst to solve all the type of problems that it might have. Using graph technologies, you can answer questions like what person met with what person, how is the criminal organization founded, and so on. These questions are very hard to answer in a tabular database, and having a graph-based solution helps you develop a more easily and comprehensive answer. What are the benefits, you might ask, of embracing connected data? One of the most important things is that you have everything in a single view of intelligence, which together with the flexible schema provided by Hume gives you rapid capability development and allows intelligence analysts to dig deeper within the complex weaves of the data to understand patterns and to reveal strong insights. So let's switch to large language models, which are the main topic of today's. Maybe most of you are common with ChatGPT, but large language models are more than a gimmick. These algorithms are trained to understand context and process information at speed. As I said at the beginning, I come from a human intelligence background, where data is often reported in an unstructured format. Using large language models, you can easily streamline that process. And for an example, in our experiments, we were able to process the information 50 times faster than a human analyst. So what's the big difference between traditional machine learning tasks and large language models? With the traditional machine learning models, you first need a data set that is carefully curated and created for that particular task. You will need to train your model, and then you'll be able to perform the tasks. Using large language models, you can skip the first two phases and perform tasks like name entity recognitions and disambiguation, and also linkage. You can have question answering, text classification, document summarization, and many other tasks. One thing I would like to mention about traditional models is that most of the models are suited for a specific task, and when the task change, you must change your model. So you must start all over with the data set, with the training, and with the task. While with the large language models, all these can be done in a single feedback. So let's go to today's scenario. So what we have here is a data set that we were going to use to analyze the Capitol riot crisis from 6th of January 2021. Our main objective is to identify suspects that have not been brought to justice yet. And for this, we will use two data sets. One from Kaggle that is developed using Twitter API. These have tweet mentions, hyperlinks, and emojis removed. The text has been obfuscated, so only public persons have usernames, and the other ones don't have usernames. Another data set that we will use is data from NPR, which is an independent nonprofit media organization. NPR is tracking federal crimes related to the 6th of January crisis, and they're providing it in this form. The data sources are directly from courts of justice in the United States, and you can have it in this format. What other tools we were going to use? The first tool that it's crucial for our investigation is, of course, Hume, where we will integrate every other tool that is used today. Most of the tools that we use are from Malfrat OSINT map, which I strongly recommend. If you're going to start investigation in open source, you can find multiple tools here. what we use here is the username and the email address. So these two sections we will use today. One of the tools that we use is H8 Mail, which is an open source OSINT investigation tool that is specialized in investigating usernames, emails that have been in current and past breaches. So they're able to access emails from data breaches, connecting persons with emails, persons with user accounts, and so on. Another tool that we use is the Harvester from Kali. It's a command line tool used for gathering information about a target domain or email address. This is a command line interface tool that is integrated within Hume. Another tool that we use is gHunt, an open source intelligence tool specifically designed to gather information about email addresses. It can retrieve owner's name, the profile, all the YouTube, Google Maps reviews, and so on and so forth. So these tools are freely available and you can use it with your own investigation. But the way we use it is together with Hume to develop a comprehensive investigation tool. So as we said before, our task today is to find persons within this database that are related to the 6th of January Capitol crisis and are not yet brought to justice. We took the data that we had and we spread it. We designed a knowledge graph schema based on that. So we have in the center the account, the tweet, message, hashtags, and keyword. The keyword was particularly extracted for this specific use case using a large language model, in this case, Mistral 7B, which can be run locally on your laptops or computers. This is the prompt that we use. We are using keyboards because we find it more relevant than hashtags. Hashtags can be user-defined and are not all the time relevant to the context and to the content of that tweet, while keywords extracted with large language models that have context are much more relevant. As you can see, we told the model to extract relevant to the 6th of January 2021 Capitol riot keywords from these tweets. And again, we gave the model an example. So this is the example that we gave, and this is the output that we are expecting. Coming back to the schema, when we mapped the data set to our schema, we realized that there are 72,000 unique accounts which share 80,000 tweets. And out of those, there are only 39,000 unique messages, which means that some of the messages were retweeted. So we created that connection here. And also we created another connection between tweets who share the same hashtag. We did the same thing with the messages. So we created a connection between messages who share the same keyword and the connection between accounts who share the same content. This is an enrichment to the data that you can only do in a graph database. So basically, we used graph data science to create this, let's call artificial connections. On the left-hand side, on this graph, you can see a representation of the world based on the NPR cases. So basically, we took all the charges and case descriptions from here, and we extracted the data and added in this way. We used the large language model in this case, also a model based on Mistral 7B, but this time it's an uncensored model. So it's trained with Dolphin data set. We tell the model who he is and what he has to do. And then we ask it to deliver the outputs in a JSON format. You can see here that to use the model with an uncensored and unbiased way, the creator of the model wrote like a fun quote in this prompt. So this must be used every time when you want an unbiased answer. So we gave it an example, like the first court order, and we gave it an output example, what we expect from the model to receive. And we can easily run this in an orchestra workflow and write the results in the Neo4j database. The node that makes the connection from the right-hand side to the left-hand side is the email node. This node is the node which is used, which uses the Malfrat OSINT map to create connections between person and accounts. So every data that we receive in this node will be used by those services integrated in Hue. So let's go to our actual visualization, and we can see that we have the accounts, the tweets, and the millions of connections that we have between these messages and tweets as well. Cool. We'll start our investigation bringing on the canvas the most relevant hashtags. So hashtags are structured based on the number of tweets referring to them. So we used a property called degree in graph data science, where we count the number of edges coming into a node and we classify them. You can see that some nodes are smaller than others. This is just a styling feature that reveals at a glance which node is more important on the canvas. And the next thing that we're going to do is going to retrieve the keywords. Again, keywords are relevant to this particular investigation being extracted with the end state in mind. We can see that some of them overlap. So the keywords overlap with the hashtags, but we also have relevant keywords that are not overlapping with the hashtags. So the next step that we're going to take is try to connect all the accounts that shared tweets that contain messages that are related to these keywords and in the same time to these hashtags. So we can do that simple operation using a cipher query. So we match every node and we return every relevant account. We can run it. It will take a little while because we have millions of connections, but in no time we'll have the relevant nodes on the canvas to operate with. So we can take a look first on this isolated node. So we can see that stock market, pandemic, travel, quarantine, lockdown, and masks are not connected to the main graph because they're not actually relevant to our investigation. And the hashtags are these hashtags that are not relevant to our investigation. Looking at the chart, we can see that we have a couple of clusters here. Let's see what we're talking about. So COVID is one main thing. Another main thing is the pandemic. We can see that this particular keyword refers to elections, and it acts like a bridge between all these subgraphs. And also Make America Great Again also acts like a bridge between these two subgraphs. If we look at the graph, we have three highlighted nodes, which are account nodes, which are the local influencers within this graph. So basically, what we do is calculate with graph data science properties like betweenness, which makes a node relevant in connecting different parts of this, different subgraphs of the larger graph. So these nodes are very relevant to our investigation. So that's why we're going to take them from the canvas, and we will start our investigation with those nodes. We can use advanced expand. feature of Hume to reveal the tweets that that particular node posted and the retweets of that tweet, the message that the tweet contains, the keyword connected, the hashtag, and the accounts who shared the content of this account. We can expand it, and let's do the same thing for these other two nodes using actions. So if we take a look at the chart, we see a big node here that appears to be more important than the others. Let's take a look. So as I said, we don't have the username or the name of the account or the email. You can see the platform, twitter.com. It has a high betweenness, which means it's a very relevant node, but not particularly to our investigation. That's why it was not retrieved in the first place. And we can dismiss this node because our investigation looks at data from Washington, D.C., and this node has location in London. We can deepen our investigation taking a look at the content of this tweet, so of this account's tweets. So we can see that there is no content relevant to the 6th of January riot, so we can dismiss this node. Immediately, the other nodes pop up, and we can take a look. So their key connection here is Make America Great Again. Let's remove everything else and try to use our services to retrieve accounts for email accounts for this Twitter account. I would like to say that the email addresses for these guys were obfuscated, so we use generic names. They can be easily retrieved using those tools and Orchestra, but we would like to keep their confidentiality for themselves, so respecting the private life. Using the tool set that we were talking about, we would like to retrieve all the other accounts that are associated to these email addresses. So we can run a workflow using Orchestra, and those services overlapped in Orchestra, and this will search the entire internet, data breaches, forums, all other platforms, and retrieve accounts based on this email address. The workflow will take a little longer, but that's why we cached the results, and we will have it here. We can easily switch styles. So for different stages of our investigation, we can use different styles. And changing the styles will reveal what type of accounts are connected to the email addresses. So we can see that they have a Discord account, Amazon account, Pinterest, and so on and so forth, using those particular email addresses. Now that we have these accounts on the chart, we can select all of them and try to return all the persons that are connected to these accounts. Again, the tools integrated within Orchestra will have to run intricate queries within all the data sources that they use, like data dumps, leaks, and so on, and return the persons connected to these accounts. We ran that before the webinar, and these are the persons that were matching these accounts. So we have Thomas Sibik, Thomas Caldwell, and Edward Baldane. Let's drop the accounts, keep the persons on the chart, and carry on with our investigation. Let's switch the style to the main style. And we can see that some of the nodes here have some indicators. These were customly created to reveal that the person has charges, which means that it has been brought to justice. Out of these 3 people, this one has not been brought to justice, and these 2 have been already prosecuted. Let's see what are the charges brought to these guys and why Thomas Caldwell is not one of them. We can easily see from the parsed data that all three persons were connected to the US Capitol and to the Capitol riot. We have multiple persons connected with each other. We have the case. Thomas Sieblich here brought some walkie-talkies. Edward Baldane brought some pepper spray, baseball bat, gas masks, and some taser. Well, all this information is extracted from this. And let's take a look at Thomas Caldwell, the main guy that we were looking for from the beginning. Why isn't he brought to justice yet? We can see that he is connected to two different persons that are on trial. So let's expand the on trial node and see what the charges are. So basically what this says is that Thomas Caldwell is working for the Department of Housing and Urban Development. And in this other case, it says that he used to be part of National Guard, and he was investigated by the FBI and the Drug and Enforcement Administration. So everything connected here is relevant to the information extracted from these two cases. So most likely Thomas Caldwell will be the next on the list, and you just make sure you're going to look for it on the NPR database once the information will go public. What we can do to further streamline this investigation is we can create an alert that will basically show us when the guy that we're looking for is posting a tweet. We can create an alert, and it can deliver us an every hour scan of the database to see if he posted any more tweets in relation to our investigation. So let's do a wrap up. So what we did here is we took the Kaggle database with the tweets, we mapped it to a knowledge graph, we extract all the information with large language models from this database, data set regarding the criminal trials on the Capitol riot. We integrated into Hume H8 Mail, the Harvester, and Ghunt in a workflow. And we searched for individuals that have not been brought to justice yet that are involved in the Capitol riots. That would conclude my part of the briefing. So if you have any questions, I'm more than happy to answer them.
Thank you, Julian. Right now, there is one question, and it's more a general question. It's going directly to you. What's your opinion how trustful using AI and LLM is for investigation? Because obviously there is a need to confirm this kind of information is coming from AI. But what about overseeing possible important information could happen if AI is not 100% perfect, and there could be a gap between the good information and that what comes up from AI. So what's your opinion about that?
So of course, LLMs are prone to some weaknesses. Some of them are hallucinations, which can easily make your data, you can render your data unusable. There are ways to mitigate this through parameters in the training of the model, or through fine-tuning of the model in relation to your particular use case. We have customers that use large language models in production, both public services like OpenAI's API or on-premises models. Those models are quite reliable, and anecdotal evidence told us that you can have a very high degree of confidence in the data that you extracted. How we usually do it is we take out a subset of that particular data, we test the reliability of the model, we experiment with multiple models until we get the reliability that we need. We tune the prompt, so the prompt has a very high impact on the results. We tune the parameters, and once we are confident that the data we extract is relevant, then we can tell a customer that this model using this prompt and these parameters can perform these tasks. Again, the way we implement large language models and any other models in our solution is to always allow a traceability. So as I showed you in the graph, you can always backtrack the information. So where did the model extracted that information, and test and validate if that particular information is true or false. So we always allow this this backtracking of information. What else you can do is with the introduction of log probes, which is another parameter, you can basically verify the information, the confidence to which the model extracted that particular information. So the model can give you by itself a percentage of confidence. And if the result is not in accordance to your threshold, you can rerun the process until you reach the threshold that you need.
Yeah, thank you for answering this. I would love to add a little bit because as I know it from my profession, working for more than 40 years in the police now and always trying to be on top what's going out. In the last years, I could see some of companies like yours working with historical data just to test their software. If they would come to the same output on working on historical data, what we already have and can confirm. So are you guys also working with historical cases, already solved ones, just to test the output of your stuff?
No, we basically use the so when we deploy a model, we use the customer data and we tune the model until the customer is satisfied with the amount, with the percentage of data that he needs. Large language models are not a patch for all problems. The best problem that they solve is the lack of personnel, because going through 1,000 cases, like we had 1,300 cases, and manually annotate the data, collate the data, and create a knowledge graph would take a lot of time. As I said in the beginning, I come from a human background, and I experimented a lot with the extraction, with large language model extracting information from human reports. One human analyst takes around 45 minutes to an hour to collate a report. Collation means extract relevant entities, relevant attributes, and relationships from that particular report. So that report is a couple of 2 or 3 pages long, and it takes you an hour. In the same time, we were able during our experiments to process up to 50 reports with a confidence rate of over 90%, which allows you, gives the analyst a great deal of time to analyze and reward or punish the model if the result is not the expected one.
Right, sounds great. So, Julian, I would love if you are able to take some notes now, because I want to go over some questions right now popping up in the Q&A section. and maybe there are some overlapping. So I will start in a second.
Okay.
So we have Jessica asking, could you run a query to show how many usernames have retweeted a particular tweet?
Yes,
And
of course.
Andrew is asking, yeah, first of all, he says, so interesting and thank you. And he loves the prompt around reward punishment for poor data. His question is around your use of data breaches as a source. Does this mean dark web is searched? Do you need to configure your own sources in Orchestra or are they automatic?
So to answer your question, these services that I presented to you are open source and can be used by anybody. We are not looking in the data breaches ourselves. Those services are doing that thing. That's why we implemented them in Hume. So Orchestra doesn't need to be configured in a special way. The way we do it is take that service, wrap it in a Docker container, install it on our server, expose an API endpoint to that, and we send a request from Orchestra to that endpoint. We receive back the response, we process the response, and we bring it to the canvas. So basically, we are not exposing the data, our precious customer data, to the dark web in the intention of enriching it. Everything is done via API calls. Everything is done in a very controlled manner, and we're not exposing anything.
That sounds good. So before you can do the answer for the question number one with the query, as I could see, you are able to do this query. I would love to go over the rest of the questions. We do have. Let me check out in real. Okay. The one of our attendees is writing open source tools are known to produce a fair amount of false positives by trying to link usernames to email addresses than to real names. How is Hume dealing with this?
So we are using these open source tools only for demonstration purposes only. When you are in production, you need to rely with a certain degree of confidence on the tools that you're using. Hume can integrate any type of tools that are offered as a service. So any API service tools can be integrated within Hume. Any type of data sources can be integrated within Hume. The way how you can do this, so to deal with false positives, is to integrate multiple tools and have an intersection of their results. Everything that is relevant is brought into the database. Everything that is a false positive can be dismissed. But of course, this means a lot of fine-tuning of the tools, a lot of fine-tuning of the data, and manual analysis, because you can only rely so far on this type of services.
All right. So as we still have a little bit time, let's go to some more questions. If we cannot fix it in our time frame, I would love, Julian, to send you some of these questions. Maybe you can answer them later, but for now, I think we are okay. So there is one of our attendees, first of all, saying thanks for the useful presentation. How do you extract edge and relationship for knowledge graph? Knowledge base or NIR LLM model?
So the way we do it usually is how I showed you, using large language models and fine-tuned prompts, few shots prompting. So we give the model one example. If we see that the model doesn't perform in the manner that we need on that particular data set, we give more examples. And at the end, we experiment with more models. So if your data is if your data can be exposed to the internet, you can use an API service like OpenAI. If your data is classified and confidential and cannot be exposed to the internet, then you can deploy a local model. You would need some hardware configuration to deploy that, and you will use this in the same way. Basically, you write a prompt, you send the information to the model, and the model will retrieve whatever you prompted it to retrieve.
Great. So the next two questions I have, I think they mean roughly the same. So Bogdan is asking, how do you solve the language issue when you have conversations in different languages? And someone else asking, what's your opinion about the possibility of LLM graph extraction from posts using local language slangs?
So we experimented with different models that have different language abilities. There are multiple open source models like Llama, like Mistral, who are able to understand different languages and also understand slang. I haven't experimented with local models with slang, but I gave some prompts for GPT-4 Turbo with slang from cybersecurity forums from the dark web, so a lot of slang, and it was in Russian language, and they were able to translate and identify relevant entities and relationships within that different language, retrieve it in English, and understand the slang. So the way you can deal with different languages is through multiple models. If you have Romanian, for example, you can use a model that understands Romanian. If you have German, you use a model that, of course, languages that are spoken by fewer people will not be well represented within a model. If you have a language that's spoken by 20,000 people within a far island in the Pacific, for sure you won't get a model that understands that language. But for English, for Arabic, for Russian, for French, for German, for a lot of Chinese, a lot of languages, you can easily find models for that.
All right. So one final question, if something more comes up, I will hand it over to you by mail. So we have the question about which data sets are used to train the LLMs. How are they existing biases in these data sets that are used to develop the LLMs, evaluated and mitigated?
So we are not developing large language models. So Graphware is not developing their own. We take models that are already developed, we experiment when we can say which model is more reliable for which type of task. But to give you an answer to your question, there are multiple types of data sets. Some of the highest quality data sets is human curated, so they're generated by humans. They are meticulously analyzed and expressing the biases of those persons. So if, for example, you have a data set with English literature of the 18th century, you will have the 18th century biases within your model because that's the data set that you used. Lately, most of the data sets, most of the smaller models are developed using artificially generated data sets. So data sets generated by other models. And this is how you can perpetuate biases from one model to the other. The way to mitigate these problems is to find models that are generated, that are trained on human generated data sets, to find models that are not trained on synthetic data, and to find models that are specifically trained to the task that you need to fulfill.
So great, Julian. Once again, thank you so much for giving us these presentations and
Thank you for having us here.
Thank you. And to anyone who's interested in having more and deeper information, feel free to shoot us an email, and we would love to forward it to Julian and his company. And I'm pretty sure you get all this answer you need. So now at the very end, as I promised, I would love to give you a briefly overview about the master's course I was talking about at the beginning of this presentations. Um, we were talking about the new Master of Business Management, Financial Crime, and Digital Technologies delivered by the European Forensic Institute. So this accredited program, approved by the Malta Further and Higher Education Authority, has an 18-month duration with online lectures and workshops. At the core of this course is an in-depth exploration of key areas such as financial crimes or digital technologies and business management. The curriculum is divided into a series of modules ranging from introduction to financial crime and fraud, to enterprise resource planning systems, data analytics, advanced web and open source intelligence, text framework, and investigations, ESG and ethics, and others. In particular, we see that the track highlights the interconnection between open source intelligence and its central role in business management and financial crime prevention. Through modules such as advanced web and open source intelligence, students and practitioners delve into the critical fusion between cutting-edge technologies and information gathering methodologies. Over the course, this training participants are honed in a variety of skills, including forensic accounting, skillful use of open source intelligence tools, tax frameworks, and investigations, corruptions and bribery detection, incorporation of ESG and ethics, and of course, the use of AI and machine learning for business strategies. This program culminates in independent research and a final dissertation, fostering an environment of scientific exploration. In a sense, this master's program aspires to equip its participants with a holistic skill set, enabling them to understand, prevent, and analyze financial crimes. It uniquely integrates the digital technologies, ethical considerations, and the strategic use of open source intelligence within the dynamic framework of contemporary business environments. So at the very end, I would say, why don't you sign up immediately for this really, really great brand new master's course? And if you need any information, I'm pretty sure everyone from the EFI team and also myself, we would be more than happy to answer your questions, giving you more informations. So let's stay in contact. Once again, thank you for joining us. And here is my very last question. Is there anyone from the EFI who wants to say the final words? I give you 5 seconds to show up. All right, here is my lovely partner, Michelle. Michelle, the floor is yours for the final words. Thank you so much.
Thank you so much, Sam, for your very generous description of our program. We're looking forward to running the Masters in Business Management, Financial Crime, and Digital Technologies, as you described earlier. This program is truly putting together 3 different sectors in that's very important today. So find out more on our website. Thank you, Sam, for the introduction. And of course, a big thank you to Lulian for this presentation today. We've been speaking for many weeks and we've been preparing for a long time to present this webinar to you. So I sincerely thank you, Lulian, and Roman as well, who's here from GraphAware. We are very appreciative of your time, and we will be sharing this recording after this session. So thank you, everybody, and thank you all the attendees. We have very good turnout today, so I wish you a very lovely afternoon and the rest of the week. If you have any questions, feel free to get in contact with us. Thank you,
Thank
Lulian. Thank you, Sam.
Thank you, Michelle. Bye-bye. Thank you, Julian, of course. Sorry. It was
you.
really, really great. Bye-bye, everyone, and see you soon.